Chapter 5 is about quadratic functions. So there's our first blank. A quadratic function is a function, so it passes a linear or vertical line test, that can be written in the standard form of f of x equals ax squared, that's new, we haven't had the x squared so far in this class, plus bx plus c. We've had things like that have an x and numbers in them. A, b, and x are all, A, b, and c are all numbers, and then we'll have our x's in there. What is f of x the same as? It's the same as y. Y is the same thing as f of x. So if you see an f of x, it's talking about y. Got it? So y equals ax squared plus bx plus c. The domain of a quadratic function is all real numbers. Right? So domain. Do you remember how we write all real numbers? The fancy R. Domain is all real numbers. In standard form, there are three terms. The x squared term, the x term, and then the one that's just a number. These have specific names. The first one is our quadratic term. It is what makes it quadratic, because it has the x squared. We've got the next one is called our linear term. If we only had a linear term, what kind of graph would it make? A linear graph, a line. And the last one is our constant term. In order to classify a function as quadratic or not, you have to look at it in standard form. Okay, standard form is where it's all written out with an x squared term, x term, and then a number at the end. We are going to use that to figure out if this function is quadratic or not. Once we've done that, we'll identify the quadratic, linear, and constant terms. So how do we simplify this equation? We get rid of parentheses. How do we do that? There's steps, and they spell out the word FOIL. Do you remember that? FOIL. What does the F stand for? First, the O is outside. The I is inside. And L stands for last. We take those terms and multiply them together. So we will get that y equals our first terms, which are 2x and x multiplied together. What do those make? We got 2 times x times x. So that makes 2. What's x times x? X squared. So our first term is 2x squared. Now we need outside terms, so that's 2x times -4, and we write plus, what's 2x times -4?
2x times 4.
Well, we're multiplying, so what's 2 times -4?
-4,
-8, and then we have our x. Alright, and then plus our inside terms. What's 3 times x? 3x. And then our last terms, 3 times -4. So we have plus what? -12. Now we just need to simplify and add like terms. Do we have any other terms besides this one that have x squared? No, so just that one. So we get 2x squared first. And then we have -8x and 3x. What are those together? -5x. And what's left over? -12. So there is our simplified equation. Is that quadratic?
Yes.
Yes, it has a quadratic term. What is that quadratic term?
2x squared.
What's the linear term?
Negative 5x.
-5x. What's the constant term?
Negative 12.
-12. Very good. Is this too bad? What about FOIL? Do you remember FOIL at all? None? None? Do you remember multiplying things like this? Maybe. It's like you're distributing the 2x to everything and then the 3 to everything. This is key. We have to know how to do this. First, outside, inside, last, and you add them all together. All right, let's do the next one if you don't have any questions. This one, it's not foiling. What do we need to do with this 3? Distribute. What are we going to do with the negative 3? Distribute. All right, so 3 times x squared is 3x squared. What's 3 times negative 2x? What's the 3 times negative 2? Okay, negative 6x. All right, then what's negative 3 times x squared? And negative 3 times negative 2? Plus 6. All right, let's add some like terms. The terms with x squared. They just become, well, what's 3 minus 3? 0. They go away. They just cancel each other out. So what are we left with? Negative 6x plus 6. So is this one quadratic? No. So the quadratic term, we will write 0, because it's not there. What's the linear term? And constant term, 6.
So even if when they cancel out, you have to cancel out the x squared too?
Yes. Because it's like you have, say, x squareds are M&Ms. We start with 3, and then we take away 3. What are we left with? Nothing. All right. Gotta love M&Ms. Any questions about this? Pretty simple so far. Let's talk about the graphs of these things. Do you remember? You see the shape over there. It's called a parabola. Very good. So the graph of a quadratic function is a parabola. It's spelled parabola. It will not infect you. Don't worry. No 21-day quarantine required. So parabolas make a U shape. Okay, when they're positive, they make a right side up U. When they're negative, that turns upside down. Just like our absolute value V's turned upside down, this will turn upside down too. All parabolas have an axis of symmetry. Axis of symmetry. That is the line that divides a parabola into 2 parts that are mirror images because it's symmetrical, so we can divide it in half. This line can be described by the x coordinate. So it will always be x equals a number. All right, so the axis of symmetry here, you go right down the middle. I do a dotted line so that I can tell the difference between it and the graph. All right, so what is the x coordinate that goes through? Where on the x-axis? It's at 0. So our equation for our axis of symmetry is x equals 0. If it was moved, 1 to the right, it would be x equals 1. But it's right down the middle right now, so it's x equals 0. All quadratic graphs have an axis of symmetry. They also all have a vertex. Vertex of the parabola is the point at which the parabola intersects the axis of symmetry. So if we follow this down, wherever we hit that axis of symmetry, that is our vertex, that point right there. So what is that for us?
0.
Right now, it is 0, what?
0, 0.
0, 0. It's the origin. Okay, that's the vertex. Vertex is always either a minimum or a maximum. For this graph, what is it? Is it the lowest point or the highest point? Minimum is the lowest point on the graph. Okay. Each point of the parabola has a corresponding point on its mirror image, so on the other half of the graph. Corresponding points have to be the same distance away from the axis of symmetry. If you want to abbreviate on your homework for axis symmetry, you can do AOS. All right, so like, say we take that point right there, 1, 1. Its corresponding point is just on the other half. So count 1 to the axis of symmetry, and then 1 more, and there is its corresponding point. Right? Because if you folded that axis of or the parabola on that axis of symmetry, those 2 dots would land right on top of each other. Any questions? No? All right, so let's look at these graphs. Let's look at these graphs and figure out all these things. So for this parabola, where is the axis of symmetry?
1.
It's at 1, so how do we write that? Is it y equals 1 or x equals 1? X equals 1. All right, and then our vertex is where? What's the coordinate?
1, 0. Wait, no. -2, 1.
Do the x and then the y.
-2.
1, -2.
Oh, yeah.
Right, over 1, down 2. All right, the first corresponding point, I did it for you as an example. So P was 0, -1, and its corresponding point, we flipped over, and it's at 2, -1. Notice that the y's are the same. That's how it will be all the time for corresponding points. The y's will be the same, x's will be different. And you write it P apostrophe 2, -1. So for Q is 3, 2. What is Q's corresponding point? If we count across, 1, 2, 1, 2. So write that as Q apostrophe -1, 2. And you see again, the y's are the same, but the x's changed. Any questions on that? Okay, tell me about the next one. What is the axis of symmetry? Go right down the middle. What is that? And how do we write it? X equals -1. What is the vertex? -1, +4, because we went up. Very good. Okay, it says P is -2, 3. What is P's corresponding point?
3, 0.
0, 3, and we write it as P apostrophe 0, 3. That way I know which point you're talking about. Okay, because on your homework you might have to do like 4 different corresponding points. If you label them with the letter and then an apostrophe, I know which one you're talking about. Okay, what about Q? What is Q's corresponding point?
-4, -5.
Oh, that's not Q. What am I doing? Okay, so Q is at 2, -5. And if we count over, so we don't get confused, 1, 2, 3 to the axis of symmetry, count 3 more, 1, 2, 3. It is Q apostrophe is -4, -5. Very good. Any questions? the point of what we're doing is they are giving us 3 points that we just see on an empty graph. 3 points, and they're saying there is a parabola that goes through those 3 points. Find it. Okay? So we're going to do that. Now, in order for it to be a parabola, they have to be non-collinear, which all that means is that they are not on a straight line. Okay, a little vocabulary there. Right, so we know these points are quadratic, but we don't know the function, so we're going to figure it out. We are going to use our standard form equation, but the only thing that I'm going to switch, just to make it easier, is I'm going to move this y equals to the other side. So it'll be ax squared plus bx plus c equals y. One at a time, we're going to take an x and a y and plug it into this. So let's start out with 2, 3. We don't know a, so I'm just going to write a. What is x? 2, so we write 2 squared plus b times x again, so that's 2, plus c equals, what's y? 3. All right, let's go ahead and simplify that. What is 2 squared? 4, so we get 4a plus what b? 2b plus c equals 3. All right, we're doing good. Do the same thing with the next point. 3, 13. Plugging into the same equation, so it'll be a times, what is our x now? 3, so 3 squared plus b times 3 plus c equals 13. What do we get when we simplify that?
9a plus 3b.
Equals 13. All right, last one. Same thing. Plug 4 in for x, 29 in for y. So a times 4 squared plus b times 4 plus c equals 29. 16a plus 4b plus c equals 29. Phew! But now we have 3 equations with 3 variables, and they're all lined up perfectly. It says use substitution, elimination, or an augmented matrix to find the values of a, b, and c. You want to go with augmented matrix? All right. What is the operation in the calculator that you use for augmented matrices?
3 by 4, second matrix.
You go into the math part and you look for R, E, F. Remember that for an augmented matrix. So while you put your matrix into the calculator, I'm going to write it out. So you'll have 4, 2, 1, 3, 9, 3, 1, 13, 16, 4, 1, and 29.
3, -5, and 1.
All right. So that mine? I'm sorry.
You were still recording.
So you should get this as the answer in the calculator. So what does A equal? What does B equal? What does C equal? 1. Okay, so now substitute back into what we started with, the standard equation. So we'll have y equals A, we just said is 3 times x squared, plus b we just said is negative 5, x plus c we said is 1. Simplify it and we have our answer. What does y equal? 3x squared. What happens with the plus times negative 5? Negative 5x plus 1. That is the equation for the parabola that the 3 points that they gave us are on. It's not that hard. It's a little bit to get it all set up, but once you got it set up, you know, matrices, they're awesome. They can help you. All right. Because that, with elimination or substitution, would not have been pleasant.